Hi fans, I'm the PC Expert Amateur, and this is episode 40 of the airflow and pressure differential comparison for 120 millimeter fans. We're getting closer to the end, but we still got quite a ways to go before we get to the end. So I want to remind you, as always, this is the anemometer or airflow meter that I use for measuring the airflow rate of my fans. Unfortunately, it only has 4 positions for decimal places, and that means it's not quite accurate enough. I calibrated it based on the Noctua A12 by 25 because it's a very famous fan. And as the numbers get larger and larger and larger, further away from the airflow level of the Noctua, that means that they become more and more distorted. So that's the bad news. The good news is that the numbers are still valid for ranking the fans. They're just distorted, that's all. And it's consistent from fan to fan. The other thing is I use cubic meters per hour instead of cubic feet per minute. You may be wondering why I don't get myself a better anemometer. Well, I only have one Patreon patron, Rudik. Thank you very much for your support all this time. And I have tried to find one on my donor site, or the donor site that allows me to pick things from, but I don't have much control over it at all. And unfortunately, the one anemometer I did find was worse than this one. So yeah, I mean, without support financially, I'm not going to be able to get myself a better anemometer. And given how hard it's been to get work, it doesn't look like it's going to happen anytime soon. So the fans that we're looking at today are the Arctic F12 Pro PWM, the Be Quiet Pure Wings 2, the Corsair ML120, the Akasa Silent Color, and this is the AK191BL. The Be Quiet is the BL039, by the way. And the Blacknoise Noiseblocker NB-Multiframe M12P is the 5th one. And the reason they call these multi-frame is because the corners are made with silicone rubber and they are removable. So that's what we've got. It's the ABCs of fans, so to speak. Let's go ahead and take a look at the results for the RPMs, and I want you to put in the comments what your guesses are as far as worst and best for airflow and worst and best for pressure differential. So please put your guesses in the comments. Don't change them after you've got them in there. This is not a competition. It's just a learning experience. And hopefully over time, you'll get better and better and better at identifying which fans will perform the best and which will perform the worst. Take a look at this and pictures, and we can see that for the first 3, they're very, very close in terms of their RPMs, and then the other 2, well, they're not. So the Akasa 1360, although it was rated for 1200, the Be Quiet was rated at 1500 and came in at 1440. The Arctic was rated at 1500 and came in at 1460. The Blacknoise was rated at 2000 and came in at 2050. The Corsair was rated at 2400 and came in at 2570. Go ahead and put your guesses down below. And in just a second here, I'm going to put up the results for airflow. And you may be slightly surprised to see that the Blacknoise actually defeated the Corsair, despite the Blacknoise being 500 or so RPMs faster. That is the way it is. RPMs are not the final arbiter of how much airflow or even static pressure a fan can achieve. It's closer to actually noise levels, but not necessarily always. So we can see that the Akasa was the worst at 112.8, and that's probably a fairly accurate number, as is the Arctic 117, and maybe perhaps even the 142.8. But when we get up to the Corsair and the Blacknoise, there's probably some distortion, although I am not enough of a mathematician to be able to predict how much those numbers are distorted based on the lack of 5 decimal places. Are you ready to look at pressure differential now? All right, let's go ahead and do that. And we can see that the Akasa has, again, taken last place, but it's tied with the Be Quiet. I'll bet you didn't expect the Be Quiet to be that low. And the Blacknoise dropped to 3rd place, but it's still 8 better than the Akasa and Be Quiet. That'll put that easily into the third quartile, possibly the fourth quartile. And the Arctic and Corsair are tied at 82 and will definitely be in the fourth quartile, because once you're in the 80s, you are doing really well. So now we're going to take a look at the overall list so we can see how these fans compare to all the other fans that are on the list so far. And since we're on number 40, that's about 200, although I did have some where I had to list them twice. But approximately 40. Also, I wanted to point out that for the Corsair specifically, I actually have two more of the same fan. I just wasn't able to locate them. I will add those numbers in when I find them. And we're starting with RPMs. And again, keep in mind that RPMs are not the major arbiter of performance of a fan. So we can see that only the Akasa is in the first quartile, but at the bottom of the first quartile. And in the second quartile, the Be Quiet and the Arctic are right there in the worst end of it, or lower end of it, I should say. Now, in the third quartile, we have nothing, of course, but we do have one. The Blacknoise is in the third quartile, and the Corsair is in the fourth quartile. Now let's go ahead and switch over to pressure differential. Okay, so we can see the Lamptron at 20 degrees is the worst, followed by, and that's the Nova, followed by the UNM Life 21, and then we quickly move into the 30s at number 7 there, and then we move into the 40s, 5 more down the row, or column, I mean. And then we only get into the 50s when we get down into toward the bottom here, but none of these fans are in that part of the list. So let's go ahead and find out where they are. Nothing in the second half of the list, but we do have the Akasa and Be Quiet in the third quartile at 68. That's pretty good. And in the fourth quartile, the other fans, Blacknoise being the worst of the three, followed by Arctic and Corsair, which are actually tied, but they're also tied with the Thermalright TLC-12C, the Reven Coldwing 12 Performance, and the Fantex T30. Who'd have thunk? I certainly am surprised by that. But, keep in mind, pressure differential is composed of airflow, pressure, static pressure, and other factors. And now airflow. Let's get right to that one. And we can see that the, how did that happen? It moved one on me. All right, so we can see that the Kingwin Advanced Series is the worst at 70.8 with the Scythe not too far away at 79.8. Not much of a difference, really, with that small of a margin. Then we jump up into the 90s with the Top Power Nanotech fan and the Nexus Real Silent Case fan, and the UNM Life actually is a little bit better, but still nothing amazing. And sadly, the Akasa and the Arctic are both in this quartile with 112 and 117 respectively. Let's see what happens in the second quartile. Oh, there's the Be Quiet. That's the only one of the 5 there. And so let's go ahead and look at the third quartile. Doesn't look like we've got anything there. But in the fourth quartile, the fourth quartile, we've got the Corsair at 228.6 and the Blacknoise at 265.8, doing decently well in this competition of fans for airflow. Now, do keep in mind, please, that airflow is great for an exhaust fan, but you need static pressure for it to be a great intake fan. So whether or not it has high airflow, if it's got high static pressure, which I'm not showing right now, then that is a great choice for intake, but it's even better if it's got high airflow as well. Obviously, if it's got high airflow and high static pressure, it's great for intake and exhaust. So let's go ahead and slide over so we can see how the fans performed and what their RPMs are. And we can see from the bottom here that the fans with the highest RPM are all exclusively at the bottom of the list. But There are some with 3,000 plus, 2,000 plus RPMs at the bottom there too. There's even one with less than 2,000, the Barrow over here. So it's pretty interesting that there's so much variance in RPMs versus airflow. And that's because RPMs are not the strongest indicator of airflow. Stronger than that would be the design of the frame and the design of the blades, the hub size, and even the gap between the frame and the blades, and the gap between blades. So let's slowly roll up here, and hopefully you can find some information here that will either help you figure out a theory as to how well a fan will perform, or you'll find a fan that will meet your needs, at least for airflow. And you'll notice that most of the fans that have high airflow are also green for the pressure differential. But there are some that have orange and red and even yellow. Or I should say yellow, orange, and even red. That would make more sense, wouldn't it? All right. And that's the end of the list. I hope that this episode has been helpful for you. I expect that we're going to be carrying on for a bit longer. It's probably going to take another, 30 episodes, maybe 20 to 30 more episodes before I've caught up on the 120s. But since I do keep on getting more 120s in, and I've fallen behind on doing the reviews for them because of my throat problem, which is better today after 12 hours of sleep for the last few days. I hope this is helping you guys. Thank you very much for watching, and have a great day.
I need to ask for your help. Things have been challenging. Whose life hasn't been challenging lately? So if you can please help me out by liking, subscribing, sharing, commenting, and turning on notifications, that would be really, really super. Also, if you'd like to help me financially and you can't afford to, you can do a super thanks on my Glenn's Fast Reviews channel, or you can become a member there. Or if you prefer, you can go to patreon.com/GLENNMII and become a member there instead. Also, I'd like to give a shout out to Bleeping Computer for their support of my channel. If you need resources for computers, for getting rid of malware and learning about cybersecurity and stuff, Bleeping Computer, BLEEPING computer.com is a great resource. Thanks so much for watching, and have a great day.